So here we have World Bank data. It's data for 188 countries that includes a surrogate for technology, internet percentage. I think we've seen this data before. GDP per capita, school enrollment, government expenditures for education, portion of the GDP that goes for education, female anemia, childhood anemia, AIDS, under 5 mortality, nurses, physicians, smokers, access to improved sanitation, labor participation here, healthcare spending as percent of the GDP, per capita healthcare spending, unemployment, male survival to 65, female survival to 65, female mortality, male mortality, and population. So we're going to want to use this data to put together a regression model. And so we're going to do analyze, correlate, bivariate, and we'll just put all these variables in to take a look at what they do. I'm going to use Spearman, not Pearson, because I don't know about normality. And take a look at our options. Aren't many. So here we go. Run our correlation, and we're interested in, for our first model, male survival to age 65. That's over here. In fact, in order to get a better look at that, let's do something to isolate that. And the way we do that is put all our variables over here, come down male survival to 65, and now we'll put the rest of the variables back in here. So we'll have it in the first column. There, it's easier to work with. And as you can see, excuse me, almost everything's significant, or much of this is significant. Internet percentage, very high. Correlation, same with GDP per capita. School enrollment, low for GDP spent on education and government spending on education, pretty high for female anemia, even higher for childhood anemia. AIDS, moderate, still significant. Under 5 mortality, very high. Nurses and physicians are high and positive. And healthcare spending per capita is high. The employment variables are not significant though, and these other indicators of longevity and health are highly correlated as well. So let's do our model. And in our first model, let's put many of these variables in the model. We'll leave some out based on what we saw in the correlation. So we go regression, linear. Dependent variable is male survival to 65. And we're going to include internet, technology, variable, anemia, AIDS, under 5, nurses, doctors, smokers, sanitation, and healthcare spending per capita. Let's put the labor participation in for now and take a look and see what happens. So, also, when we do this, take a look at the statistics, and that's fine there. Let's do plots, and we're going to do SD residuals on the y-axis and dependent variable on the x, and let's look at a histogram and a normal probability plot. So we're going to continue, hit OK. And as you can see, here's our model summary, adjusted R-square, which is R-square less the number of variables. It's 0.923. That's really high. In fact, it's too high. We'll talk about that in a minute. Good F value is significant. So this means that 92% of the variance is explained. This indicates that the model has explanatory power, that it's not white noise. And here are our model coefficients. The constant term is significant. Some of these other variables are not, including doctors and nurses. And look, the sign went negative for those. And smokers and labor. So let's take some of these variables out. We've got a lot of variables in here anyhow. So, excuse me. We're going to take out under 5 because it's measuring the same thing as male survival. And nurses and doctors are probably collinear, so we'll take out nurses. Smokers didn't seem to influence much, so we'll take that out. And labor, we'll take that out as well. GDP per capita we want in. Okay, let's see what we have. Okay. So our adjusted R-square is now 0.855, which is still really good. And the F value is 124.177, so it's significant. We're explaining 86% of the variance, and we have a model with good explanatory power. And when we look down here at our variables, neither healthcare spending per capita nor GDP is doing much in the model. So let's go ahead and take those out too. Analyze. Regression. Linear. And they were probably collinear to begin with. Okay. So we have 0.853 for our adjusted R-square, still very good. 172.6 for F. So we're explaining most of the variance, and the model has good explanatory power. And now all of the coefficients except physician are significant at P equals 0.05. And basically, this is a good model. Take a look at the residuals. This is almost a normal curve, a little bit skewed left. And we've got fairly good tightness in terms of the residuals and the unit line. So this is a cumulative distribution function here. And here from our scatter plot, mostly white noise, although maybe we can see a sort of a linear trend here that maybe we want to think about. But by and large, decent model. We could tinker with it in terms of some of the variables, but that's how you do a linear regression in SPSS and how you interpret the results that you get, and a little bit of insight into the art of modeling, what you include in the model and not.